the planet Uranus. Have you ever imagined a world so mysterious, so far away, and so alien that even in our most advanced telescopes it looks like a pale, bluish-green marble lost in the darkness of space? A planet that rolls around the sun on its side like a forgotten ball tipped over in the cosmic playground, defying the rules that guide its planetary neighbors. That strange, cold, and captivating world is Uranus, the seventh planet from the sun, often overlooked, often misunderstood, yet holding secrets that could transform the way we see our universe. While planets like Jupiter and Saturn steal the spotlight with their enormous size and iconic rings, Uranus sits quietly, waiting for us to unlock its hidden wonders. But beneath its calm, icy-blue appearance lies a world of violent winds, extreme cold, tilted mysteries, and a history that challenges everything we think we know about how planets form and evolve. Uranus is not just another distant planet. It is a cosmic enigma, a frozen giant with a personality unlike any other. It is the only planet in our solar system that spins sideways, as though it were knocked over by some ancient cosmic collision. It is home to faint rings, dozens of moons, and storms that rage across its icy atmosphere at supersonic speeds. For centuries, humans had no idea Uranus even existed. Unlike Mercury, Venus, Mars, Jupiter, and Saturn, visible to the naked eye since ancient times, Uranus was too dim, too subtle, too far away to be noticed. It took the careful observation of a man with a telescope in the late 18th century to reveal this hidden world to human eyes. That discovery changed astronomy forever and expanded the boundaries of our known solar system. Yet even today, Uranus remains a mystery. Only one spacecraft, Voyager 2, has ever visited it, and that was in 1986. For a few brief hours, humanity got its only close-up look at this strange planet. Decades later, the data still fuels debates, theories, and curiosity. We know that Uranus is an ice giant, smaller than Jupiter and Saturn but larger than Earth and Neptune, with a strange atmosphere of hydrogen, helium, and methane that gives it its unique turquoise hue. We know it has faint rings, tilted magnetic fields, and a family of moons named after characters from the works of Shakespeare and Alexander Pope. But what we don't know could fill volumes. Does Uranus have a rocky core? Could its moons harbor hidden oceans beneath icy crusts? What secrets lie beneath its icy blue clouds? To truly understand Uranus, we must journey far into the outer solar system, across billions of kilometers of empty space, into a realm where sunlight is dim, temperatures plummet, and the very definition of a planet takes on new meaning. This is not just the story of Uranus. It is the story of human curiosity, exploration, and the endless quest to uncover what lies beyond our reach. The story of Uranus begins not in the depths of space, but in the study of a quiet musician-turned-astronomer in the late 18th century. For centuries, humanity's vision of the cosmos was limited to the five wandering stars visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. Beyond Saturn, people assumed, the heavens were empty, stretching into infinity with no other planets to disturb the silence of the outer darkness. Saturn was the boundary, the final world, the edge of creation as seen by ancient civilizations. That was the belief until March 13, 1781, when a German-born British astronomer named William Herschel pointed his homemade telescope toward the night sky and stumbled upon something extraordinary. Herschel was not a professional scientist at the time. In fact, he had been a musician, a skilled oboist and composer, before turning his passion toward the stars. He constructed his own telescopes, grinding and polishing mirrors with painstaking care, and used them to scan the heavens. That fateful night, he noticed what seemed to be a small, faint, greenish object in the constellation Gemini. At first, he thought it might be a comet, since it appeared to move slowly against the background of stars. But as he and other astronomers tracked it over the following nights and months, it became clear. This was no comet. It was a new planet. For the first time in recorded history, humanity had discovered a planet beyond Saturn. This was not just an astronomical achievement, it was a philosophical revolution. It meant that the solar system was larger than anyone had imagined, that the cosmic map had new, uncharted regions. The discovery of Uranus shattered the old boundaries and ignited the imagination of scientists and dreamers alike. After its discovery, the question arose, what should this new world be called? Herschel himself suggested naming it Georgium Sidus, or Georgia Star, in honor of King George III of England. While this name pleased the monarch, it did not sit well with astronomers outside Britain, who felt that a planet should not be named after a contemporary king. Some suggested it should be called Herschel, in honor of its discoverer. But in the end, the German astronomer Johann Bode proposed the name Uranus, after the ancient Greek god of the sky, the father of Saturn, Cronus, and the grandfather of Jupiter, Zeus. This naming convention preserved the mythological lineage of the planets, aligning Uranus with its celestial family. Over time, Uranus became the accepted name across the scientific community, though the debate lingered for decades. The discovery of Uranus had consequences far beyond its own existence. Astronomers began carefully measuring its orbit, and they noticed something strange. Uranus didn't move exactly as predicted by Newton's laws. Its path seemed to be tugged by some unseen force. These irregularities sparked one of the greatest detective stories in science, as mathematicians proposed the existence of another planet even farther away, influencing Uranus's orbit with its gravity. This led directly to the discovery of Neptune in 1846, making Uranus not only the first planet discovered with a telescope, but also the key to finding another hidden world. The existence of Uranus also challenged humanity's sense of place in the universe. For thousands of years, people had believed the cosmos was limited, with Earth at the center or, at least within a small circle of planets. Now, Uranus pushed the boundaries outward, showing that the solar system was vast, dynamic, and perhaps filled with more secrets yet to be revealed. For astronomers, Uranus was proof that science could rewrite the limits of human knowledge. For philosophers and poets, it was a symbol of the infinite. Even today, the discovery of Uranus reminds us of the power of curiosity and persistence. Herschel was not looking for a planet that night. He was simply observing the sky, following his passion. Yet his careful attention to detail and willingness to challenge assumptions gave humanity a new world. In this way, Uranus stands as a monument not only to science, but also to the spirit of discovery itself. If there is one feature that makes Uranus stand out as a true oddball in our solar system, it is its axial tilt. Every planet in the solar system spins on an axis, a line running through its poles, and most of them tilt slightly relative to their orbital path around the Sun. Earth, for example, has a tilt of about 23.5 degrees, which is what gives us our familiar seasons. Saturn tilts at 26 degrees, and even Mars has a tilt of about 25 degrees, making its seasons somewhat similar to ours. But Uranus takes this concept and flips it literally. Instead of spinning upright like a top, Uranus rolls around the Sun on its side with an astonishing tilt of 98 degrees. Imagine Earth rotating not with its poles pointing up and down, but with its north pole almost where the equator should be. That is Uranus. It is a planet that spends half its orbit with one pole basking in constant sunlight and the other pole plunged into endless night, each lasting about 42 years. For almost half a century, one hemisphere of Uranus stares directly at the Sun, soaking in what little warmth it can from the distant star, while the other hemisphere freezes in darkness. Then, as Uranus continues its 84-year orbit, the situation reverses, and the once dark pole becomes the one in sunlight. This sideways spin is not just peculiar, it is a cosmic mystery. How did Uranus end up this way when no other planet in the solar system shares this feature? The leading theory suggests that billions of years ago, Uranus was struck by a massive object, perhaps as large as Earth, in a violent collision that knocked it over. Such an event could explain not only the tilt but also some of the strange features of its moons and rings, which may have formed from the debris of that ancient impact. Some scientists even believe Uranus might have experienced multiple giant impacts, each adding to its unusual rotation and magnetic anomalies. This tilted world also rotates in a strange manner. While most planets, including Earth, rotate from west to east, Uranus rotates in the opposite direction, making it a retrograde rotator, like Venus. But the difference is that Uranus does so while lying sideways, combining two peculiarities into one. It completes one rotation in about 17 hours and 14 minutes, which means its days are shorter than Earth's. But because of the extreme tilt, the concept of day and night becomes complicated on Uranus. Near the equator, the planet experiences a somewhat regular cycle of daylight and darkness, but near the poles, entire decades can pass in continuous sunlight or darkness depending on where Uranus is in its orbit. Adding to this strangeness is Uranus's orbit itself. Positioned about 2.9 billion kilometers, 1.8 billion miles from the Sun, it takes Uranus roughly 84 Earth years to complete one journey around our star. That means if you were born during one Uranian year, you would live your entire life on Earth before Uranus completed a single trip around the Sun. A child born when Uranus is at one point in its orbit would see that planet return to the same spot only as a grandparent. This immense timescale gives Uranus a sense of slow, cosmic grandeur, its years unfolding like chapters in a book far longer than any human life. The combination of its tilted axis and long orbital period makes Uranus one of the most seasonally extreme planets in the solar system. Imagine a summer lasting 42 years followed by a winter of equal length. These prolonged seasons have profound effects on the planet's atmosphere and weather patterns. When Voyager 2 flew past Uranus in 1986, it was during the planet's southern summer, and the entire southern hemisphere was bathed in sunlight. The northern hemisphere remained shrouded in darkness. It wasn't until decades later, using the Hubble Space Telescope and other observatories, that astronomers began to see seasonal changes sweep across the planet as its poles traded places in the sunlight. The sideways spin of Uranus also affects its magnetic field, which, as scientists later discovered, is just as strange as the planet itself. Unlike Earth, where the magnetic field is neatly aligned with the planet's rotation, Uranus's magnetic field is tilted by nearly 60 degrees from its axis and offset from the planet's center. This creates an uneven, lopsided magnetosphere that wobbles chaotically as the planet spins. Such a bizarre magnetic setup may also be a consequence of the colossal impact, or impacts, that tipped Uranus long ago. In the grand ballet of planets orbiting the Sun, Uranus is the dancer who breaks all the rules, spinning sideways, moving backward, and tilting so dramatically that its seasons defy imagination. To astronomers, it is a puzzle box, one that forces us to rethink what a planet can be. To storytellers and dreamers, it is a reminder that the universe does not conform to our expectations. The cosmos, after all, is not a place of uniformity but of endless variety, and Uranus is one of its most striking examples. At first glance, Uranus looks like a calm, featureless world, a smooth ball of blue-green light floating in the black ocean of space. When Voyager 2 first flew past Uranus in 1986, its photographs showed a planet that appeared strangely uniform, lacking the dramatic belts and swirling storms seen on Jupiter and Saturn. To many, Uranus seemed dull, a cold and lifeless ice giant without the theatrical weather displays that define its larger siblings. But as more powerful telescopes, like the Hubble Space Telescope and advanced Earth-based observatories, later turned their gaze toward Uranus, a very different story began to emerge. Beneath that calm turquoise mask lies an atmosphere of extreme winds, violent storms, and a coldness unmatched by any other planet. The color of Uranus is one of its most striking features. Its soft cyan or aquamarine glow is caused by methane gas in its upper atmosphere. The planet's atmosphere is composed mainly of hydrogen, about 83%, and helium, about 15%, with a small but important amount of methane, around 2%. While this may sound like an insignificant trace, methane plays a powerful role in shaping Uranus's appearance. Methane molecules absorb red wavelengths of sunlight and scatter the blue and green wavelengths, giving Uranus its signature hue. This makes Uranus look like a giant blue-green marble suspended in the void. But the beauty of that color hides a turbulent reality. Uranus's atmosphere is layered, with the upper regions made of hydrogen, helium, and methane, and deeper layers possibly containing icy water, ammonia, and methane clouds. These thick, icy layers swirl and shift under the force of Uranus's winds that can blow at speeds of up to 900 kilometers per hour, 560 miles per hour. To put that into perspective, these winds are faster than Earth's most violent hurricanes and move at nearly the speed of sound. Despite the planet's distant, cold environment, Uranus's atmosphere is anything but still. The temperature of Uranus is another extraordinary characteristic. It is the coldest planet in the solar system, with minimum recorded temperatures dropping to about minus 224 degrees Celsius, minus 371 degrees Fahrenheit. Even Neptune, which lies farther from the Sun, is warmer on average. This has baffled scientists for decades. Normally, giant planets emit more heat than they receive from the Sun due to residual energy from their formation. Jupiter and Saturn, for example, radiate vast amounts of internal heat, driving their weather systems. But Uranus is different. It emits almost no excess heat at all, radiating only about the same amount of energy it absorbs from the Sun. Why is Uranus so cold? One theory suggests that the same catastrophic collision that tilted the planet sideways may also have caused its interior heat to escape into space, leaving Uranus without a strong internal heat source to fuel its atmosphere. Another possibility is that Uranus's internal structure somehow traps heat instead of releasing it. Whatever the cause, the planet's frigid nature makes it an extreme environment where the faint warmth of the Sun provides little relief. Despite its coldness, Uranus is home to storms and cloud formations that rival those of other gas giants. While Voyager 2 saw only a bland world, later observations revealed large, bright storm systems appearing in its atmosphere, some as big as Earth itself. These storms form when convection currents push methane ice clouds high into the upper atmosphere, where they reflect sunlight and become visible as bright spots. Some storms have been observed lasting for months, moving across Uranus's surface as massive whirlwinds of icy gases. Adding to this drama are the seasonal changes driven by Uranus's extreme tilt. When one pole faces the Sun for decades, the atmosphere warms unevenly, creating giant circulation patterns and driving storm activity. As Uranus progresses in its orbit and the seasons shift, the energy distribution across the planet changes dramatically, sparking new weather systems. Astronomers studying Uranus over time have witnessed these transitions, watching storms emerge, fade, and reappear as the seasons evolve across the decades-long cycle. One of the most fascinating aspects of Uranus's weather is its dynamic bands of clouds and winds. Though not as obvious as the colorful stripes of Jupiter or Saturn, Uranus has faint cloud layers and jet streams running parallel to its equator. These bands carry winds at incredible speeds, especially near the equator, while the poles seem calmer by comparison. Advanced infrared imaging has revealed subtle cloud features hidden from visible light, proving that Uranus is far from the tranquil orb it once appeared to be. In addition to clouds of methane, scientists suspect that Uranus may harbor deep layers of exotic ices in its interior, ammonia, water, and methane compressed into strange, high-pressure states. Within these depths, temperatures and pressures may be so extreme that methane breaks down, releasing carbon atoms that form diamond rain. Imagine colossal storms in which diamonds fall through the atmosphere like hailstones, sinking into the depths of the planet. While this remains theoretical, laboratory experiments under simulated conditions suggest it is possible, and similar processes may also occur inside Neptune. The strange stillness of Uranus, observed by Voyager 2, was not a sign of inactivity, but rather a snapshot during a relatively quiet season. Today, modern observations show us a restless planet, full of storms, rapid winds, and unique atmospheric chemistry. Uranus is a world of contrasts, outwardly calm, inwardly violent, strikingly beautiful, yet unimaginably harsh. Its weather systems remind us that even at the edge of the solar system, far from the sun's warmth, the laws of physics and chemistry conspire to create atmospheres that are dynamic, powerful, and alive with motion. Uranus challenges our expectations of what a cold planet should be. It teaches us that distance from the sun does not mean stillness or silence. Even in the frozen reaches of the solar system, storms rage, winds howl, and worlds breathe in ways that are as unpredictable as they are spectacular. For scientists, understanding the weather on Uranus is not just about studying a distant planet. It is about testing the very limits of atmospheric science, learning how worlds evolve under conditions utterly alien to Earth. When people think of planetary rings, Saturn almost always comes to mind, with its dazzling, luminous bands stretching wide across the solar system. But Saturn is not the only world to wear a crown of rings. Uranus, too, possesses a system of rings, fainter, darker, and far more elusive, but no less intriguing. Discovered in 1977, the rings of Uranus were the second such system ever found, forever changing the way scientists viewed the outer planets. No longer was Saturn unique. Instead, rings appeared to be a common feature among the gas and ice giants.
The discovery happened by chance.
Astronomers James Elliott, Edward Dunham, and Douglas Mink were observing Uranus as it passed in front of a distant star. They expected the star's light to dim briefly as the planet blocked it. But to their surprise, the star's light flickered several times before and after the main occultation, as though something else was obscuring it. These mysterious interruptions revealed the presence of narrow, thin rings encircling Uranus, invisible to telescopes at the time, but detectable through their shadowy dance with starlight. Today, we know that Uranus has 13 distinct rings, composed mostly of dark, carbon-rich material. Unlike Saturn's bright, icy rings, which reflect sunlight brilliantly, the rings of Uranus are faint and opaque, almost like dusty shadows circling the planet. They range from narrow ribbons only a few kilometers wide to broader, diffuse bands stretching across thousands of kilometers. Some are so thin and sharp-edged that they appear as cosmic razor blades slicing through the void. The material making up these rings likely consists of small rocks and icy particles, coated with a layer of radiation-darkened carbon. The origin of Uranus's rings remains an open question. Some scientists believe they formed from the debris of shattered moons, broken apart by collisions or pulled apart by Uranus's immense gravity. Others suggest they may be remnants of material that never fully coalesced into moons in the first place. Whatever their source, the rings are not static. They are dynamic, shifting under the gravitational influence of Uranus's moons, which act as shepherds, keeping the rings in place and preventing them from dispersing into space. And that brings us to Uranus's moons, a remarkable collection of natural satellites, each with its own story. To date, astronomers have identified at least 27 moons orbiting Uranus, and unlike the mythological naming tradition of other planets, Uranus's moons draw their names from the works of William Shakespeare and Alexander Pope. Thus, instead of gods and titans, Uranus is orbited by characters from A Midsummer Night's Dream, The Tempest, and other literary classics: Titania, Oberon, Ariel, Umbriel, Miranda, and many more. The 5 largest moons, Titania, Oberon, Umbriel, Ariel, and Miranda, are particularly fascinating. Titania, the largest, spans about 1,600 kilometers in diameter, making it roughly half the size of Earth's moon. Its surface is marked with deep canyons and icy plains, evidence of tectonic and geological activity in the past. Scientists speculate that Titania, like some other icy moons in the solar system, may harbor a subsurface ocean beneath its frozen crust. Oberon, the second largest, is darker and more heavily cratered, with ancient scars suggesting a surface largely untouched by recent geological processes. Yet even here, the possibility of a hidden ocean cannot be ruled out, as tidal forces and internal heating may have shaped its interior. Ariel, the brightest of Uranus's large moons, displays a young and dynamic surface, with smooth plains, ridges, and valleys carved by past activity. Its bright ice reflects sunlight, making it stand out among the darker moons. Ariel's relatively few craters suggest it has been geologically active in recent times. Umbriel, in contrast, is one of the darkest moons of Uranus. Its surface is heavily cratered and ancient, with mysterious bright spots that may be deposits of ice from past impacts. Umbriel seems like a frozen relic, a world of shadows compared to the brighter Ariel. And then there is Miranda, perhaps the most bizarre of them all. Though only about 470 kilometers across, Miranda looks like a patchwork world stitched together from different pieces. Its surface is a chaotic jumble of giant cliffs, ridges, and valleys, including the towering Verona Rupees, a cliff that may be up to 20 kilometers high, the tallest known in the solar system. A fall from its edge would take several minutes before hitting the ground below. Miranda's bizarre, fractured terrain suggests it may have been shattered and reassembled multiple times in its history, possibly by collisions or internal upheaval. Beyond the 5 major moons, Uranus's smaller satellites add even more variety. Some, like Puck and Sycorax, are irregularly shaped and likely captured asteroids or fragments from ancient collisions. Others orbit farther out, tilted or retrograde, hinting at violent histories of capture and disruption. Collectively, they form a diverse family of worlds orbiting a tilted giant, each moon contributing to the story of Uranus's past. The interplay between Uranus's rings and moons paints a picture of a dynamic, interconnected system. Moons tug at the rings, shaping their edges. Rings shed particles that may settle on moons, darkening their surfaces over eons. Together, they are not just companions of Uranus, but active participants in its cosmic ballet. For astronomers, the moons of Uranus hold special interest because some may conceal hidden oceans beneath their icy shells, just like Europa and Enceladus around Jupiter and Saturn. If this is true, then Uranus's moons could be more than just frozen rocks. They could be potential havens for life in the distant reaches of the solar system. The idea that oceans might exist beneath the surfaces of Titania, Ariel, or even Miranda gives scientists compelling reasons to return to Uranus with future spacecraft. In this way, Uranus is not just a lonely blue-green planet drifting in space. It is the heart of a miniature system, complete with rings and moons, each piece telling a different chapter in a story that stretches back billions of years. To explore Uranus is to explore not only a planet but also a family of worlds orbiting together in a strange, tilted harmony. Peering beneath the calm, bluish clouds of Uranus is like staring into a locked treasure chest. We can only guess at the riches or secrets hidden inside. Unlike rocky planets such as Earth or Mars, Uranus has no solid surface. If you tried to land a spacecraft on Uranus, it would sink through thick layers of gas, ice, and fluid until it was crushed by pressure and heat. What lies deep within the ice giant is one of astronomy's great mysteries, a puzzle still waiting to be solved. Scientists classify Uranus as an ice giant, along with Neptune. While Jupiter and Saturn are considered gas giants, dominated by hydrogen and helium, Uranus and Neptune contain far higher proportions of heavier elements, water, ammonia, and methane ices, that shape their structure. But the term ice here doesn't mean frozen water, like the kind in your freezer. In the extreme conditions inside Uranus, these substances exist in exotic forms, superheated, pressurized fluids that behave in ways almost unimaginable on Earth. The uppermost envelope is mostly hydrogen and helium with trace amounts of methane, which give the planet its color. This layer gradually transitions downward into the deeper regions, blurring the line between atmosphere and interior. Beneath the outer envelope lies a vast mantle of water, ammonia, and methane ices, though ice here refers to chemical composition rather than temperature. This mantle makes up the bulk of Uranus's mass and volume, extending thousands of kilometers deep. Under immense pressure, these substances may transform into superionic fluids, where oxygen atoms form a solid lattice while hydrogen ions flow freely through it, creating exotic states of matter unlike anything on Earth. At the very center, scientists believe Uranus may have a small rocky core, perhaps a few times the mass of Earth. But unlike Jupiter and Saturn, whose massive cores drive powerful gravitational compression and heat release, Uranus's core is relatively modest and cool. This could explain why Uranus emits so little heat compared to other giant planets. One of the most fascinating theories about Uranus's mantle is the possibility of diamond rain. Deep inside, under crushing pressure, methane molecules could break apart, releasing carbon atoms. These atoms may then crystallize into diamonds, which fall like shimmering hailstones through the mantle, slowly sinking toward the core. Experiments on Earth simulating the pressures of ice giant interiors support this idea, suggesting Uranus could literally have oceans of liquid diamond, with giant diamond icebergs floating inside. While this may sound like science fiction, it's a real scientific hypothesis that underscores just how alien the planet truly is. But perhaps the greatest mystery of Uranus's interior is its magnetic field. On Earth, our magnetic field is generated by the motion of molten iron in the planet's outer core, producing a relatively stable, centered field aligned closely with the planet's axis of rotation. Uranus, however, does not follow this neat pattern. Its magnetic field is tilted about 59 degrees from its rotational axis and is offset by nearly one-third of the planet's radius from its center. This creates a highly lopsided, asymmetric magnetosphere that behaves chaotically as the planet spins. The result is a magnetic environment unlike any other in the solar system. As Uranus rotates on its side, the magnetosphere wobbles and twists, opening and closing to the solar wind in unpredictable ways. This produces strange patterns of charged particles and auroras, shimmering lights in Uranus's atmosphere similar to Earth's northern and southern lights, but far more irregular. Voyager 2 detected these auroras, though they were faint and unlike the symmetrical displays seen on Jupiter or Saturn. Why is Uranus's magnetic field so strange? One explanation is that it is not generated by a central core, but instead arises from the motion of conducting fluids in its icy mantle. If electrical currents flow in a shallow shell around the planet rather than deep inside, the resulting magnetic field would naturally be tilted and off-center. Another possibility ties back to Uranus's violent history. A giant collision billions of years ago may have disrupted the planet's internal layers, leaving its magnetic field permanently skewed. This magnetic oddity has important consequences for Uranus's space environment. The tilted, shifting magnetosphere interacts with the solar wind in complex ways, sometimes trapping charged particles and sometimes releasing them suddenly. If a spacecraft were to orbit Uranus today, it would encounter a magnetic field that changes dramatically depending on its position, sometimes weak, sometimes strong, always unpredictable. Together, the interior and magnetic mysteries of Uranus reveal a world that defies simple models. Unlike Earth, Jupiter, or even Saturn, Uranus is not a planet that fits neatly into categories. Its low heat emission, sideways tilt, and off-kilter magnetism all suggest a violent, chaotic past and a present filled with exotic states of matter. For scientists, Uranus represents both a challenge and an opportunity. A natural laboratory to test theories about planetary formation, extreme materials, and the diversity of worlds in the universe. And perhaps that is the greatest lesson Uranus offers. It reminds us that planets are not all alike, that nature invents endlessly varied designs. In its icy depths, its diamond storms, and its crooked magnetic shield, Uranus whispers of possibilities beyond Earth's imagination. To understand Uranus is not only to learn about a single planet, but also to expand our vision of what worlds can be. For all its strangeness, for the tilted axis, icy storms, diamond rains, and lopsided magnetism, Uranus remains a planet we barely know. In fact, it is one of the least explored worlds in our solar system. Only one spacecraft, Voyager 2, has ever flown past Uranus, and that was more than 3 decades ago, in 1986. Voyager 2 spent just a few hours in the planet's vicinity, capturing images, measuring magnetic fields, and sending back precious data before continuing on toward Neptune and eventually interstellar space. Those fleeting hours gave humanity its first and only close-up look at Uranus, but they also left us with more questions than answers. Voyager 2 revealed a pale, featureless world with faint rings and a collection of moons, some bizarre and fractured, others dark and ancient. It detected the tilted magnetic field and measured the planet's unusual lack of internal heat. Yet many details remained hidden. What is the true structure of Uranus's interior? What drives its strange seasons and its extreme storms? Could its moons hide subsurface oceans, making them possible candidates for extraterrestrial life? These questions linger, waiting for the next generation of explorers to answer. In recent years, interest in returning to Uranus has grown rapidly among scientists. The Planetary Science Decadal Survey, which guides NASA's exploration priorities, has identified Uranus as a top target for a flagship mission in the coming decades. Unlike Jupiter and Saturn, which have been studied extensively by missions like Galileo, Juno, and Cassini, Uranus has been left in the shadows. Yet studying it could provide key insights not only into the history of our own solar system, but also into the countless exoplanets orbiting stars across the galaxy. Why Uranus? Because in many ways, Uranus is not an oddity, it is a prototype. Astronomers studying exoplanets have found that ice giants similar to Uranus and Neptune are among the most common types of planets in the Milky Way. If we want to understand the universe, we must understand Uranus. By studying its atmosphere, its magnetic field, and its moons, we can learn how these worlds form, evolve, and possibly even support life in hidden oceans beneath their icy crusts. Future mission concepts include orbiters that could spend years circling Uranus, mapping its magnetic field, measuring its atmosphere, and closely studying its moons and rings. A probe could even be dropped into Uranus's atmosphere, much like the Galileo probe at Jupiter, to directly sample its gases and shed light on its composition. With modern technology, far more advanced than Voyager's 1980s instruments, such missions could revolutionize our knowledge of this ice giant. The moons of Uranus, in particular, are tantalizing targets. Worlds like Titania and Ariel may harbor subsurface oceans warmed by tidal heating. If so, they could contain the basic ingredients for life. Just as the discovery of hydrothermal vents on Earth's seafloor reshaped our understanding of where life can thrive, exploring Uranus's moons could show us that even in the cold, dark reaches of the outer solar system, life might find a way. Imagine the possibility that hidden beneath kilometers of ice, in oceans shielded from radiation and extreme cold, microbial life could be swimming in alien seas. If true, that would mean life is not limited to the warmth of planets like Earth, but is far more universal. But beyond the search for life, Uranus also holds the key to planetary science. Understanding why Uranus emits so little heat, why its magnetic field is so tilted, and how its extreme seasons drive atmospheric dynamics would help refine our models of planetary formation. It could even help us better understand Earth's own evolution, as scientists compare planets' geophysical processes to those of the giants in the outer solar system. Exploring Uranus also carries a symbolic weight. For centuries, humanity has looked outward, expanding the boundaries of the known. From discovering Uranus in 1781 to sending Voyager past it in 1986, each step has redefined our sense of scale. To send a new mission to Uranus would not just be an act of science, it would be an act of vision, a continuation of a story that began when William Herschel looked through his telescope and spotted a new world. And so, Uranus waits. It waits in the cold, dim reaches of the solar system, its turquoise glow shining faintly in the dark. It waits with its tilted spin, its storms and rings, its family of moons. It waits for the next spacecraft, the next chapter in humanity's exploration. Perhaps within our lifetime, a probe will descend into its atmosphere, cameras will map its moons in detail, and scientists will finally unlock the mysteries hidden for billions of years. In the end, Uranus is not just a distant planet, it is a mirror of our own curiosity. It reminds us that the universe is stranger, grander, and more complex than we can imagine. That even in the quiet corners of space, worlds of wonder exist. That discovery is endless. When the day comes that we return to Uranus, it will not simply be about studying an ice giant. It will be about answering questions that touch the very heart of who we are. Are we alone? What is our place in the cosmos? And how far are we willing to go to find out? Until then, Uranus remains a silent guardian at the edge of visibility, a turquoise beacon of mystery, whispering to us across billions of kilometers.